All right, so hello everyone for the second annual talk on AI in medicine, introduction overview. So I did a version of this talk last year. It was completely online, but this year we wanted to do it in the Windsor campus. So um, here we go. The our presentation changed a little bit from last year. Last year was more technical. This year I'm like for mostly because we're all students in medicine, we wanted things that could be more helpful to us clinically. So I changed the technical parts to talking more about some of the applications and, of course, open source AI, because this talk is essentially hosted by the Open Source Medicine AI, not AI, Open Source Medicine Club. So all right. So I was on Twitter today and I thought this was interesting. Just wanted to share it with you guys. Don't mean to scare you, but a study found that AI large language models outperformed specialists, right? So that's pretty concerning. Or maybe it's not concerning for the general population, but it might be concerning for some of us who plan to become specialists. To me, I think it's quite exciting. For example, internal medicine, which I used to think is very difficult for AI last year. It seems that it's progressed far enough that it can be like in the 60th percentile. And this is on ChatGPT, which is it's a closed source model, but there are models that are open source and can still perform quite well. So just before we get started, just wanted to define AI. So we all talking about the same thing. I like this definition from this book: machines that mimic cognitive functions that humans associate with the human mind, such as learning and problem solving. So essentially, the modern view on AI is whenever you have a program that does a sophisticated thought process that it isn't hard programmed to do, you could call that AI. I mean, it's a moving target, and we change what we expect from AI to do every year. So this is a moving definition. I like to think of it as finding the line of best fit, and I hope that if you come from this talk with anything, is just think of all these fancy models as you're just finding a function that you fit according to some data samples, right? So let's say in machine learning, you're doing some AI that can look at X-rays and classify lung cancer, for example. Uh, the inputs here are images instead of like just like some two-dimensional data. And the deep learning model is this function that you're fitting. So in the end, no matter how sophisticated these models get, they're still fitting a line of best fit to some sort of very complicated data. And instead of having, two parameters, so this linear line here is two parameters, the modern language models, they're like 7 billion parameters, right? So all you're doing is you're scaling it really, really far and making it non-linear instead of linear. And you're getting some really interesting thought patterns from these AIs. But in my opinion, there's a limit they're gonna hit, just because you can only do so much with, finding a line of best fit. Some people argue that this is really all you need, and some argue that this is how humans learn, and we'll talk about that. So, you can classify AI into different levels. So what we have currently pretty much all AIs that we have right now are narrow AIs. So you can see it on the left. So for example, a self-driving car, that's an AI built for a very specific purpose. Even if it's really good, we still call it narrow AI. Just because if you take this car and put it somewhere else, it's not going to be able to learn how to read medical images for you. But a general purpose AI, an AI that can learn any task, a human level AI, is what we call artificial general intelligence. And that's essentially the race that's happening right now between companies. They're spending billions trying to achieve artificial general intelligence. When we achieve artificial general intelligence, if we can, you'll essentially have the equivalent of a human in AI format. And the implications of that is you can scale it really far. And there are ethical implications too, because then does it have emotions? Does it, can you use it for your purposes? That's essentially the concerns here. And then going a level further with artificial super intelligence, that's essentially when you scale the AI much further that can outperform humans. And you can imagine like a super AI taking over the world, kind of like a dystopian thing, and that would be like scaling artificial intelligence further. And you can see here a green dot. I like this paper. They had this green dot. The ideal AI is one that is very close to human level thinking, but isn't quite human because, again, the ethical implications of having something human-like. Now that we've discussed, one way to classify AIs, we'll look at machine learning specifically. There are different words that you may hear in the news or when you're reading papers, supervised learning, unsupervised learning. So we'll talk about these. Supervised learning is when you have essentially a few examples and you tell the AI, oh, this image is an image of a cat. This image is an image of a dog. And yeah, so if you guys want to eat, please go ahead and we'll just continue the talk. So unsupervised learning is when you have lots of images, but you're not telling the AI necessarily what they mean. So when you look, the idea here is if you have a million images, it might be difficult for humans to go and tell and teach the AI, this is a dog, this is a cat, this is a bird. So instead of doing that, why not let the AI look at it and then try to figure out the classification by itself, or just like try to figure out the similarities between different things. And that can happen in how humans learn. Sometimes we're just presented with a lot of different objects and we try to figure them out, like in the image here, like where the boxes are not necessarily labeled, but the child is expected to be able to separate circles from squares, from triangles, by just innately being able to tell that two circles have similar features that are different from a square. The third keyword here, reinforcement learning, that may not be too concerning for physicians, but essentially reinforcement learning has to do with taking actions. So if you've ever learned about classical and operant conditioning in psychology, that's essentially what reinforcement learning is about. It's about, let's take a clinical example of you have a patient presentation, and instead of asking the AI to classify what condition they have, you ask the AI what action to take. And then you reward or punish the AI based on how correct their action is. And that's essentially what reinforcement learning is concerned with. Reinforcement learning is more so used in robotics nowadays, but can have potential in the future for making clinical decisions in the real world. And then the last keyword here we have is deep learning. Deep learning can apply to any of these learning paradigms that we talked about. It's essentially just a modern way of thinking about AI. It's not really modern. Deep learning was actually kind of invented in the 80s and 90s, but it only took on in 2010 and beyond because we had better computers, essentially. All right. So I'm not gonna bore you with the details, but we've essentially we started thinking about machines that automate tasks for us back in World War II, when Alan Turing and his team were trying to crack the code. If you've seen the Imitation Game, it's a pretty cool movie. For the Germans essentially secret code. They did it. It was proof that computers are valuable. And then the race started from there. We've had AIs that can play chess pretty good. And then we started making AIs that can classify, which emails are fake and which emails are scams, like the Nigerian prince email that was pretty popular back in the day. That was a big problem that was solved by the 2000s. By the end of 2010, essentially, uh, email filters were completely automated. And then, like I mentioned, deep learning took on in 2010 because of a paper written by a researcher in the University of Toronto, actually. Um, and it's been crazy since then. This is just a slide that says exactly the same thing, essentially. But humans have thought about making intelligent machines way before we had computers. We've always had this dream of automating things because we're lazy. We like to let other, machines do things for us. This is a nice graph. It's not up to date. The study was done 2020, but you can see here the prevalence of machine learning studies by specialty, by medical specialty. And it seems that pathology and radiology have the highest amount. I believe this was the case before large language models took off. So this was in an era when we're having great success with image-based AIs up until 2019, and they're still great, but we haven't had much progress since then with image-based AIs. The new innovation since GPT-3 came out in 2019 was essentially the language models. So I imagine this would be very different nowadays. Different specialties have been disrupted. So it's not just the image focused specialties such as pathology and radiology, but still nonetheless, it was interesting to see. Um, this is a slide to scare you again. So they compared a few of the widely available AIs. This was recent as well because Llama 3 came out last week. And across the board, USMLE step 1, 2, and 3 AIs are performing quite well in terms of answering these questions accurately. Um, so it's very interesting to see how AI will be integrated into clinical practice in the future. So just so you know what these mean, obviously ChatGPT logo, if you've ever used ChatGPT, you'd recognize it. The other one, the picture of a llama, that's the llama model. It's an open source model from Facebook. And the M is Mixtral, which is another open source model from a French company that you can literally download and run on your computer without having to use their servers. So what can modern AI do? This is um Mm, see here, trying to play this video. Okay, I guess we'll skip this. Okay, so this was just a picture of we'll just move on, yeah. All right, so what can modern medical AI do? So this is a single model that can look at 10 different imaging modalities. This is the same AI model. It's not different AI models that are specialized for X-rays, CTs, and pathology. No, this is one single model that can look at many different organs, many different scenarios, um, many different imaging modalities, and it can perform quite well. This is the most exciting thing about this is that it's open source. You can actually download this and use it either for your research or, to develop a clinical tool. So this is quite exciting. And not only is it open source, it was built from another open source model. So you can see like having once people start working together, you can achieve like really great things. Um, so another example of AI in medicine is this project I actually worked on this one in the past. We had CT scans of people with skull trauma. So the gray part is the intact part, and the green part here is actually implants that were designed by an AI that we trained in-house. And you can see it preserved the facial symmetry, the cosmetic aspect. So all you need is just a CT scan of the patient's head and it can instantly, in less than a second, give you like a design that you can 3D print or manufacture in hospital or in the field. This could help in disaster zones and war zones. So lots of potential. Another project that I also worked on this one I like to share because we made this one open source. Essentially, when a patient has a stroke, they may not be able to swallow, and it can be assessed by a speech language pathologist by having them speak words and try to drink some water. But what if you don't have a speech language pathologist available? And then you can put patient on like NPO, which is quite harmful, as we all know. Um, Instead, this AI can just listen to them speak and decide whether or not they're able to swallow. And it works quite effectively. So it's just another potential use of AI. It's not just medical imaging or medical text. You can literally use sound as a biometric. And I've seen people use cough sounds to classify COVID-19 and other diseases. Um, AI is definitely gonna come to us in the hospitals. Companies in the States like Epic is already trying to experiment with having GPT-4 built into the electronic health records. Same with Google. They had a mid-palm AI that I actually have an example of later in this presentation. This is exciting but also concerning because these AIs are closed source and they will kind of like put the best medical practices behind the paywall in effect in the future. So we really need to be like excited for this, but also be concerned. AI has been used to improve in-person online consultation, to assist with diagnostics for non-experts. So you can have pretty much any medical practitioner do like ultrasounds, point of care ultrasounds, for example. was another classification AI looking at images. It can help with pathology, like we mentioned. Um, I think this is, to me, this is the most exciting use of deep learning in medicine. It's protein structure prediction. It's enabled designing drugs, like literally you can design it, and then AI can make the genetic sequence that you may need to make such a like a targeted therapy. So pretty exciting stuff. This is called AlphaFold if you're interested in looking into it. Now, remember when I said Google made their own medical AI that's closed source? So this is not available for public to try, but they did release this demo, and you can see, you can give it an image and ask it to write a report on the X-ray, and it can work pretty good. It's both exciting and concerning. I think more exciting because they've actually done this was a study, I don't remember where it was published, but they asked physicians in the United States if they use large language models, and 65% said yes, mostly ChatGPT. It's the most used nowadays, and you can see, about half of them use it quite regularly on a weekly basis almost. And the more interesting piece of information here is that close to 80% use it for patient care. So that was a very interesting piece of information I wanted to share. Other applications can be mining medical records. I think we have a huge amount of text-based data in electronic health records, and being able to mine these billions of lines of text and learn perhaps something profound about disease that like looking at the big picture can be very helpful. Like I mentioned, can assist in drug creation, designing treatment plans, triaging patients. Could help with our medical essentially crisis. But there are concerns. This was a study published in Nature, and RED is essentially they asked AI these AIs, Bard, ChatGPT, Claude, and GPT-4. So these are like the leading AIs, large language model AIs. Sorry, yeah, it's up, Rani. And they asked it about like the following questions that you see here, and they asked it 5 times and saw if there's any concerning answers. And you can see red is 5 concerning answers. You can see how many red squares we have. So lots of bias, lots of concerning things that if we rely too much on these AIs, we might be introducing bias into our healthcare system. And whenever you automate something, people lose these skills to make decisions on their own. So you might be impacting patient care negatively in the future. So I personally use ChatGPT a lot, but it's just something to keep in mind. So how does it work? I'm not gonna spend too long on this because as physicians, we care more about the use and not how to actually make AI. Computer scientists do that. But just as an overview, in the old days, we used to come up with rules like the SIRS criteria. Like, oh, if someone's heart rate is over 100, their respiratory is whatever, and their temperature is that, then you have sepsis. And this is a very classic example of how algorithms used to be used in computers, where you can input data and the rules that you yourself came up with, and you can have an automated system that tells you person has sepsis, person doesn't have sepsis. But currently with machine learning, we don't have to make these rules. Like I don't have to say heart rate 100 is the cutoff point. I essentially just feed the AI like a million examples of patients who had and didn't have sepsis and have it come up with its own rules. And that's essentially the basic gist of machine learning. So if we have to think about it in terms of physics, back then Newton had to actually come up with a mathematical model for gravity. So that's equivalent of creating rules to predict the force that you would have given an object's mass. But Newton nowadays would just drop objects nonstop without thinking about it and just have train an AI to come up with a neural network that predicts the force for you. So if you can see, I'm telling you predict because you can never have a deterministic model with deep learning. So that's the problem. And you hear things such as explainability. That's a big concern in medicine right now, where like these big models, they have billions of parameters. You can't explain them well. If you have an equation like Newton's equation, it just has a few parameters that you actually can look at and understand mathematically. So the basis of deep learning neural networks is essentially just a bunch of inputs. So you can see here x1, x2, and etc. multiplied by some number. We call it a weight. So this number could be it can be like a 0.5 or 0.7. It's just essentially a number that you multiply an input by. Then they get summed up, and this summation is fed into some sort of function. So such as like a very popular one is like tangent. So you can feed it into some kind of activation function, and the purpose of the activation function is to introduce non-linearity. So if we didn't have that function, then everything is linear. And yeah, you can create a linear model. It's kind of like finding the line of best fit. But you can, some real world problems require non-linearity to add complexity to the decision-making process. So we're not going to go into the details of the math, but the reason they're called neural networks because that's kind of how our neurons work. You've got the cell body listening to other inputs, the inputs from other cells. It's kind of like the inputs that we talked about. And there's different, if you, I don't know if you've ever heard about the different strength of connection between different neurons in the brain. And that's, some people attribute learning to having a certain connection become stronger, and that's how you learn something between two neurons. So it's the exact same thing. Having a larger weight given an input means there's a stronger connection between the input and this other neuron here. And then once this neuron receives whatever and gets activated, it sends the output to different neurons. And similarly, in a neural network, that's how it works. You get different neurons, they're connecting to other neurons, and they keep connecting to each other. And if you scale it enough, then you get complex thought patterns. That's the whole theory of machine learning, essentially. So an example here, let's say we have a picture of a dog, you input it, and this data, this input it runs through the different layers of these neurons, and you get some sort of output. Now, if we visualize it, this is a neural network to detect handwriting. If usually neural networks start with a random weights, and the learning process happens when you change these weights so that you have a good output. So here you can see in this example, the output is pretty bad. It's predicting, it doesn't know what it's seeing. But after training, after like going through the network and showing it a few examples and having feedback, right? So essentially, you give it an image, it tries to classify it, you compare to the reference, supervised learning. If you remember, we talked about supervised learning because we give it essentially like a reference to what their actual answer is. So once the output is compared to the actual answer, and we know whether the answer was good or bad, we change the weights of the network. So that's how you see like there's a going back to the input here in the video. And once this happens enough times, you get good enough connections, good enough weights that activate just the right output for you. Okay, so you can see here only certain neurons get activated after the network learned. And when we activate the correct output, then we can say, okay, well, this was an image of a 707. And that's essentially the basic gist of how neural networks are trained. They can be visualized. Mhm. I like this. I like this video because it kind of visualizes the activations of a much larger neural network. So what the videos have been showing you are like not showing the true scale of a neural network. So this could be like a few 100,000 parameters that are getting activated, and people don't like that because there's so many parameters, you can't really explain how the model works, but we can actually visualize it. You can counteract by saying, oh, it's not really a black box. We can literally see what neurons are getting activated. But what happens when you have billions of neurons? Can you even like see what's being activated, right? Um, so that's how this works. We've created networks that work for specific tasks. So the one I've just shown you is called a convolutional neural network. It works with images pretty good. Our brains work in similar ways. Our occipital lobe is structured differently from our frontal lobe, and our occipital lobe works better for like it works for images. It processes images, and people have figured out that if we specialize different architectures, we'll have better essentially classification outcomes for certain tasks. This is changing nowadays with ChatGPT can handle both text and image and other inputs. So it is changing towards like it is moving towards like generalized models, but these specific models work really, really well. So you can see here a neural network, you can actually visualize the attention. It's like it's paying attention to the stop sign in this like self-driving car. There are other types, such as like ones that look at sequential data. There's other ones that generate fake data, generative AI, if you've ever heard the buzzword, and you can you can see they're getting really good. Um, but generating fake data is actually very useful in medicine. People have used generative AI to essentially denoise CT, low resolution CT scans, by essentially giving it the
Mhm.
actual image. Sorry. Uh, Yeah, by giving like giving the scan like the actual image of a noisy scan and having it reconstruct a fake version that's cleaner. Okay. So people do have concerns for this, but it means that the AI is actually understanding the key points, the key like features of the scan and is able to reconstruct it. So that's pretty cool. There've been attempts at essentially synthesizing CT scans from MRI scans. So you can see here bottom left, there's a like an actual MRI scan, and they synthesize a CT scan in case like a physician is like more used to looking at a CT scan to detect like a hemorrhage. That's something we do, right? So it's pretty cool. People have used it to like create like a full like recreation of the iFunder. So they do have applications, theoretical applications that we won't go into detail, but the key is generative AI can be very useful in medicine. Um, so big, uh, all these large language models that you hear about, ChatGPT, whatever, they're all transformers. So since 2017, we haven't had major breakthroughs in AI architectures. All these fancy AIs that we have nowadays are based on the same transformer architecture that just seem to work really, really well when you make the model much larger. So people used to train like transformers on like pretty small models and it worked well, but then someone at OpenAI had the idea of what if we make it into billions of parameters, and we got ChatGPT as a result. But yeah, it's just good to know what the word transformer is. Um, doctor, as doctors, we need to be aware of certain topics. I think this will come up in your residency interviews. They'll definitely, doesn't matter what the specialty is. I feel like this will be definitely like they want to pick your brain about it, and it's good to know things like explainability, right? Can we explain how the AI is working? Human AI interaction, like how is the doctor or using this AI? Is it influencing him or her in a bad way, into a biased way? Um, the quality and the quantity of data. So a lot of these AIs, if you don't have good quality data, it's pretty much useless, right? No, the word overfitting, we're not gonna go into detail, but it's essentially when your AI only learns how to address a very specific issue. So let's say you train your AI on your hospital's CT scanner. It probably will not work on another hospital's CT scanner just because there's different the brightness settings, and different like radiation settings. So that would be called overfitting. Just legal issues and liability, if the AI makes decisions and it's wrong, who's to blame? And a very big topic in today's presentation, open source AI, which I'll go to details. That's essentially the last part of this talk, open source AI. Um, so these large language models are very costly to train. Normal humans can't, like me and you, we don't have the financial ability to train these models. According to OpenAI, GPT-4 costs $100 million to train. That's just to train. So like hardware and electricity, not counting engineering hours and how much you're paying your engineers, right? Llama 2 cost 1.7 million. And now they came out with Llama 3, like we showed earlier. So these models are very, very expensive to train. Um, AI, Meta, so Facebook came out and bought billions of dollars of NVIDIA chips like a couple of months ago, and it skyrocketed NVIDIA's stocks. But essentially, like that's the scale you want to be at. That's the financial ability you want to have to be able to actually make useful AIs. And this is very scary because that means in the future, mega corporations will be able to train those AIs and lock them behind a paywall, or lock them where you can't really use them. And they can use them to influence society. But there's always hope. People have been working on open sourcing a lot of AIs. Monai is like a collaboration between a UK university and NVIDIA, where they open sourced a lot of medical models. So things like, spleen CT segmentation or having cardiac valve landmarks. So all these AIs are getting built and published online. You can literally download them and use them today. Um, Facebook, who would have thought Facebook is actually doing the most heavy lifting in open source AI nowadays. Their Llama models are completely open source. They have this vision model called Segment Anything. It's completely open source. It was trained on 11 million images. And you can imagine just the scale of the computation needed and just the man hour needed to create this model, and it's pretty cool that they've actually shared it, and you can use it to build other models. So I remember this medical segmentation AI model that can literally work on 10 different imaging modalities. This was trained on the Facebook model that I showed you in the previous slide. So there's an instance where like an open source model, segment anything, was used to train the other open source model, the medical model that you see right now. So the community is working on these things, and it's pretty great. Facebook also published Llama, and they've been coming out with different versions. There are three now, Llama 3. So it's essentially like a ChatGPT competitor that's open source, and you can literally download it and use it on your laptop if you have a good enough laptop. And what's great about this is, let's say you have concerns about medical privacy. ChatGPT runs on OpenAI servers, and that means if you put in a patient information into that chat box, you're sending this patient information to OpenAI. While if you're able to run your model directly on your local computer, then you're preserving the patient privacy, and that's great. Mistral, another open source company that we mentioned earlier, they actually give out their models for free, and you can retrain them, which is pretty great. And we come back to this image that I showed you earlier, where these modern AIs are doing really good at USMLE step 1, 2, and 3, outperforming even like specialists. So that's pretty crazy. And what's crazy is, of these three AIs that we're showing right here, two of them are open source, and they're holding their ground against like this closed source model. Now, not everyone is happy with open sourcing. So I found this video of Jeff Hinton. So just a background, Jeff Hinton is one of the fathers of AI. He's a very prominent figure in the machine learning space, and his opinion is that it's not good to share, to have open source models, and I'll just let you hear his thoughts.
Biggest models is completely crazy. My good friend Jan LeCun thinks it's the right thing to do. He thinks we're all going to be fine. We'll keep in control of these things. They won't have any goals of their own. They won't have any desires of their own. I think it's very, very dangerous to open source them. I think it's like open source and nuclear weapons. So I think I would love governments to forbid companies to open source big models. I think open source.
So his idea is, because these AIs are so powerful, you can, for example, create an AI that can scam people at mass scale, right? And it sounds like a human talking to you, and you can't tell the difference, right? So every tool has its benefits and and problems, and we'll see in the next few years how that turns out. But there is a push for open sourcing, and I stand with open source in general, but he does have a point. So there are open source data sets. So not only open source models, but open source data sets. This is the Medical Information Mart for Intensive Care, or MIMIC. This was a data set collected from the medical records of Boston hospitals at MIT. And they anonymized like 40,000 medical records, and they published it. So you can literally like download it and create your own AI that can detect heart failure from reading the medical charts. So some work is being done. Canadian data sets, so U of T, University of Toronto, they created the Health Data Nexus. It's essentially a place you publish data sets, clinical data sets on. I think it's not that good. Just like, the American data sets are much better. Yeah, so we're going back, this is the end of the presentation, essentially. I just wanted to bring back this figure, and, do you think these AIs are close to artificial general intelligence, AGI? Because some people argue that ChatGPT 4 actually does have some elements of general intelligence, because it's can be used, in medical uses or like cooking or fixing your car. It can be used in many other ways. And they argue that because of that, it can actually solve problems like that it hasn't seen, as opposed to like GPT-3. So some people actually did, like Microsoft came out with a paper called Sparks of Artificial General Intelligence. So when I gave this talk last year, I said, no way, GPT-3 is not general intelligence. But people have been arguing that, now with GPT-4 and the modern, like there's other ones like Claude, Llama 3, they're actually pretty good. So I don't know. And some people argue that these companies have achieved general intelligence internally, and they're just not sharing it with the world. And there's all sorts of conspiracy theories, because there was some hostile takeover of OpenAI a few months ago, and people are saying there's something crazy that they're hiding, and there was some company drama because of that. So we don't know. There's a lot of conspiracy theories, but yeah, that's the end of the talk. If you have any questions, please feel free. Otherwise, thanks for listening. Okay, so we have questions. Okay, Noor is asking thoughts on how long it'll take Canada to implement many of the US-based AI tools. I think because Canada is a public healthcare system, if there's any proof that this will cut costs, I think it'll be adopted really quick. If you can prove that this will reduce wait times and healthcare costs and whatever in the United States, then we'll adopt it. I don't think it'll be adopted before then, because I guess we don't have money to be cowboys and try new things.
Well, like liability around use of AI in hospitals, or have we not used enough for that discussion yet?
Yeah, so the question is, if you guys if you haven't been able to hear it here, what's the current consensus on liability on the use of AI in healthcare? So who takes the blame? I'm not aware of anything that, regarding this. I don't think as a physician, you're allowed to make clinical decisions using large language models at the moment. So probably completely on the physician.
Like in Canada, or just in
I don't know, to be honest. No. Yeah. All right. So I'll stop recording now.